Okay, welcome back again. Today we will proceed fluid kinematics, which is very important topic in hydraulics. So we will see the detail now. I hope everything is okay from the previous topic. Now, what is fluid kinematics? So kinematics of fluid deals with the geometry of motion, that is space-time relationships of fluids, only without regard to the forces causing the motion. So when we say this, just the motion may be in three-dimensional axis or two-dimensional axis. So they are generally deals with velocity and acceleration of the fluid particle. So let us see now. So a fluid system refers to a specific mass of fluid within the boundaries defined by closed surface. The shape of the system and so the boundaries may change with time, as when liquid flows through a constriction, as fluid moves and deforms, so the system containing it moves and deforms. So we may have closed boundary or fixed boundary when a fluid is going inside these boundaries. So we will have some velocity and acceleration of these particles in three-dimensional axis. So let us see the detail now. So this is just three-dimensional axis of fluid particle. So you may have x and y and z axis. So you may have dx, dy, and dz. So you have this axis which is streamline, and this is the velocity vector that moves in this direction. So you may have u, which is the x direction velocity, and w, which is the z direction, and v is in y direction. So we may have any point we can consider such points, which is this point maybe at any point we can find at any position. At any position we can find the velocity of this fluid particle. You can see this one, which is the streamline, which is going. This is the streamline. So you have streamline, which is this line, and then you can have velocity vector v, which is just this one, when at any point x plus dx and y plus dy, at any point when you go at this point, what will be? So you have dr, position vector of this velocity, then you can find at any point the velocity magnitude with theta and etc. So just we can see this just plane. You have motion of the fluid, which is air motion. So you can just consider what it is complex dynamic and complex three-dimensional axis. So you can just study on this also. So let's go to the first example. Dimensions of the flow. Find the velocity vector and its magnitude for the velocity components u 3xy minus t, v 2yz plus t plus 1, and w 1 plus 3ty at a point a 3 to 1 meter at t 2 seconds. So when t is 2 seconds with these position vectors on three-dimensional axis, what will be the velocity vector and its magnitude? So let us see. So you have just as a solution, the coordinate of the fluid particle is given as this one, 3 to 1, and the velocity components you have at a point 3 to 1 are calculated as just simply you substitute in each coordinate axis, then you can find the velocity components u, v, and w. So you substitute the values of these coordinates, then you get u, which is in x direction velocity 16 meter per second, and v 7 meter per second, and w 13 meter per second. So the velocity vector at a point 3 to 1 is given by this equation. So this is the general equation for velocity vector, which is ui plus vj plus wk. So you simply substitute the other values, then you can find this result 16i plus 7j plus 13k. So once you find this velocity vector, so you can find the magnitude of the velocity using this relation, under square root of u square plus v square plus w square. So you get this result. So this is the magnitude of the velocity with this position and at t 2 seconds. So when t is changing, everything will be changed. Okay, so the second example is streamline. So you have velocity vector in two different flow field are given by this equation 2xi minus 2yj. This is one velocity vector. What will be the streamline? The streamline at a point 32. At a point 32, what will be the streamline function? In the second case is v velocity vector 2x cube I minus 6x square yj. So let us find the solution. For the first case, let us see for this velocity vector. So you can take out from this coefficient of I is u. This is u component velocity, and v minus 2y. Then you can find now the stream function is given by this equation. This is the streamline function dx over u equal to dy over v, or just you can crisscross this one. You can crisscross v dx, just crisscross v dx equal to u dy. So integrating both sides, you can take this one. So integrate dx over u, which is u is this component. You bring here, you substitute, and v is this one. Again, you substitute in this equation. So integrate both sides. So integration of 1 over x is known. So you may cancel on both sides. So ln x equal to negative ln y plus ln c. So you can just calculate now. So you can bring this one into this position, which is ln xy equal to ln c. Then ln can be cancelled out. So this is the equation. So once you find c value, then what will be the value of c? So the streamline passes through this point, through 3, 2. So once the streamline coordinate is known, then it must satisfy the expression xy equal to c. So xy equal to c, then you substitute 3 in place of x and 2 in place of y. So 3 times 2 is 6, then c will be 6. Hence, the required streamline function is xy equal to 6. So this is the streamline function. So for the second case, for this velocity vector, again, you have u, coefficient of I, you bring this one, and v is negative 6x squared y. So this is v. So since you have the streamline equation, you simply substitute dy over dx is equal to v over u. You can rearrange, or dx over u, dy over x, as the previous slide. So you can just have streamline equation. Then dy over dx, you can substitute v over this one, just for simplification. So we can simplify by 2 by 2 minus 3. Then integrate both sides. Again, you have ln y for this case, ln y, and then minus 3 ln x plus ln c, since it is indefinite integral. So you have to have c constant. So we have this equation. Then according to logarithm property, if you have summation with the same base, you can multiply by times this one. So this is again, you go to this exponent, so x cube. So this is ln yx cube is equal to ln c. Then we can cancel ln. Then this is the c constant. Hence the streamline passes through the point 3, 2, and thus it must satisfy the expression. So you simply substitute the coordinates 3 and 2 in place of x and y respectively. Then c will be 54. Hence the streamline equation is this one. So this is the streamline equation, which is f of xy in both direction. You can substitute. And third example is velocity and acceleration of Eulerian method. This is the third example. find the velocity and acceleration components at a point 1 to 3. You have x, y, z coordinate and t 2 seconds. For the fluid flow described by the velocity vector, you have velocity vector is given, coordinate given, then what will be the velocity and acceleration components. So A1 to 3 represents the point at A, which is the coordinate x, y, z. The velocity components at a point 1 to 3, which is just at time t 2 seconds, are calculated as follows. Let us see. You have just substitute u, just x, you have 1, then you get 2 meters per second. Again, v, substitute -10. By substitution again, w, you get 6. So this is the velocity vector for this coordinate. For this coordinate, you have this velocity vector. So this velocity vector will be just magnitude. You can find this one. So this is v magnitude. So you can just calculate now. You have just since this velocity is given, then we can find now other parameters. So del u with respect to del x will be just you can find to complete acceleration. Just you have u component which is 2x cubed. This is component. The component which is 2x cubed, then partial x, then you get 6x squared. Then you have del u with respect to y again. This is just with respect to y, no y value here, no y. So it will be 0. And del u with respect to z, just we are just derivating for the variable u with respect to z. So there is no z here, z variable, so it will be 0, 0. Then del u with respect to t again, to just derivate with respect to t, 2x cubed with respect to t. No t variable, so it will be 0. Then the acceleration in x and y components can be computed as first you have to have acceleration, which is this equation. The acceleration in x component will be u del u with respect to x plus v del u with respect to y, w del u with respect to del z plus del u with respect to del t. Then thus you have to substitute each above values. Then you have acceleration in x component 12x the power of 5. So the acceleration in x direction at a point, at this point 1 to 3, and at t 2 seconds is calculated as follows. So you simply substitute the value. Since you have x, so we have one coordinate, then you have to have this acceleration in x component, you have 12 meters per second square. Then we have again del v with respect to del x, you have coefficient of j, you have minus 5x squared. So with respect to x, you derivate, then you get 10xy. Del v with respect to del y. So you have y component, so it will be minus 5x squared. Since this is just multiplication product, so you keep constant. Other variable will be constant and derivate with respect to y. So you get this result. And del v with respect to del z, which is just no z variable here, you simply make 0. And del v with respect to del t, no t variable in this equation, then you have 0. Then since ay is given by this equation, which is derivate v with respect to x times u plus v del v with respect to del y, w del v with respect to del z plus del v with respect to del t. So all v will be derivated and you multiply by the components of the fluid particle. So you have here u and here v for the y component. So you simply substitute the values and the results here. Del v with respect to del x is given. Then you can find this one, then you multiply, then you get this result. So the acceleration in y direction at a point 1, 2, 3. At this point and t 2 seconds, you have to substitute the values x to the power of 4, y, 5x to the power of 4 times y. You simply substitute the 10 meter per second square. So this is acceleration in y components at point 1, 2, 3. When the full particle reaches 1, 2, 3 at 2 seconds, you have 10 meter per second square. And the acceleration in z component can be determined as this one. So you will just derivate again del w with respect to del x. So we have this equation. This is a general equation for acceleration in z component. Then you have to have del w with respect to x, which is this one. So w component you have 3d with respect to x, it will be 0. Then again with respect to y, 0, no y value here, no y variable. Here again, no z, so it will be 0. Then with respect to t, it will be 3. So you simply substitute these values and then you multiply each term, then you find the result. So x, we have component x coordinate, we have 1, and y, you have 1, 2, 3, and z, no z value, so you have this is acceleration in z direction. So once you compute acceleration in z direction, then you can find the magnitude of acceleration. So the acceleration in z direction at this point, which is at 2 seconds, when t is 2 seconds, you have az 3 meter per second square. Then this is the acceleration vector, which is axi plus ayj plus az. Okay, so once you have this, then this is the magnitude of acceleration, which is ax square plus ay square plus az square equal to 12 square plus 10 square plus 3 square. Then you get this result. So this is the acceleration of the particle, the magnitude of the acceleration, the magnitude of the acceleration of a fluid particle at a point 1, 2, 3, and when time is 2 seconds. Okay, as exercise, we can try this one, find the velocity and acceleration components of a fluid particle just as a position, position vector are xy, 2i plus j plus 3k. So when t 5 seconds for the fluid described by, this is the velocity vector given. This is the velocity vector given. So you can just have velocity, which is coefficients. You can have u component and v component and w component. So once you have this, then you can find the velocity and acceleration components. When this is the coordinate is given, then you can find. So you have just xi and yj plus zk. So you have the coordinate, then when this is the position vector, then you can find. So the velocity will be this one. Then magnitude will be just as the previous, you just square each and under square root, then you have this result, and acceleration vector will have this result. Then finally you have this one. So this is just as exercise. And the other example is continuity equation, steady flow, the steady flow. So we have a pipe of 1 meter in diameter carrying water at a velocity of 4 meters per second. So you have here v at 4 meters per second, which is diameter given. So the diameter is 1 meter. Is branched into 2 pipes. The first branch is 0.6 meter in diameter. So this is D1, and this is D2. So D1 and D2. So and just the first branch is 0.6 meter in diameter, and it carries 1/3 of water flow, 1/3 of the total flow rate. So if water flows in the second branch with a velocity of 3 meters per second with this one, you have V2 here with this one, V2, then determine the flow velocity in the first branch, of the pipe and diameter of the second branch. So what will be this one, D2, and you have here 1/3 of Q. So you have Q here, total flow rate you have, and velocity you have. Then in the first pipe, 1/3 of the flow rate. It is going 1/3, 1/3 of Q, 1/3 of Q. So what will be the velocity in the first branch, which is V1, required V1? What will be V1? How much? And D2, how much? D2, how much? So these are the questions. Now let D 1 meter and V 4 meter per second. D1 Q 1/3. Q1 is 1/3 of the Q, and D2 is given 3 meter per second. Let Q be the total discharge, which is this one. D1 is just the water velocity in the first branch pipe, and D2 be the second diameter of the pipe. Then what will be the result? So Q, first you have to find total flow rate. Since you have total velocity, then area times velocity, so area is pi over 4d squared times v. Then you get this result. Then finally, you can find Q1 is total Q over 3. Then 1/3 of the total Q will be 1.0472 meter cube per second. Then V1 you can find now. V1 is Q over area. From continuity equation, you have Q1 over A1. So you simply substitute the values. Q1 is already known from the above expression, which is from the above result. You substitute here, then pi over 4 times V1 squared. So you get V1 velocity. Then to find Q2, Q2 is just total Q. You have total Q is equal to Q1 plus Q2. It is branched into two pipes. So the total flow rate is the sum of the two. Then you can find from this equation, you can find Q2. So Q2 is Q minus Q1. So once you find this result, which is the flow rate in the second pipe, then you go from continuity equation, you can substitute A2. So A2 is Q2 over A2. Then you simply substitute the values. Then you have velocity already given. For the second pipe, it is 3 meters per second, which is this one. This is a given quantity, so you simply pi over d2 square equal to this one. Then d2 will be this result. So this is the second diameter of the pipe. So I think this is all about today's tutorial. So thanks for watching. So if you have any question, please comment and forward. Thank you very much. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section below. I will definitely reply on it. So please like, share this video with your friends and subscribe to my channel to get more videos on similar examples. And thanks for watching.